So I had a request from somebody in class to do another reduction of order example. So I know that was a really tricky section for us when we first went through it, and I wanted you all to understand the method instead of just the formula that WebWork uses. So hopefully now that you've had a chance to do your participation and your homework, kind of like it's clearer the questions we have about this section. And so seeing another example might help you understand kind of how to proceed with those problems. So I've copied here my version of, I think, the second problem in your homework. So the numbers might be different, but it should look familiar to you. And now if you look at it, you'll even notice that it's a Cauchy-Euler problem. So our solutions are going to be x raised to some power usually, and we might see that when we find the second solution of this problem. But we're going to solve it with reduction of order, not our new method. And so we're given y1 equal x to the fifth. And what we always do in reduction of order problems is we assume that the second solution is some unknown function u times our first solution. And then because we don't know anything about that function u, we try plugging it in to our differential equation. And then hopefully that tells us something about how u has to behave in order for y2 to be a solution to the differential equation. But to do that, we're going to need to know the derivatives of y2. So we're going to go ahead, and if y2 is ux to the fifth, then when I get y2 prime, I'm going to have to do a product rule. I'll get u prime, take derivative first, leave the second the same, plus 5x to the fourth times u, leave u the same, take derivative of the second. And then my second derivative, y2 double prime, is just going to be two product rules. So I'm going to get u double prime x to the fifth plus 5x to the fourth times u prime. That's all a product rule on the first term. Plus u prime 5x to the fourth. So take derivative of u, leave this first term the same, plus 20x cubed u. Take derivative of 5x to the fourth, multiply it by u. And then something that's always going to happen with these reduction of order, like double product rules, is that you're going to have a term from the product rule on the first and second part of the first derivative that kind of combine. So I saw that 5x to the fourth u prime twice. I'm always going to end up with double, whatever that term was, 10 u prime x to the fourth. If you don't see that happening, it's like a signal that something went wrong in your product rule, and you should kind of go back and check your calculus. But now that I have my two derivatives, I can go ahead and plug everything in. So my y2 double prime is right there, u double prime x to the fifth, plus 10 u prime x to the fourth, plus 20x cubed times u. Then my plus 5x y2 prime is right there, u prime x to the fifth, plus 5x to the fourth times u, minus 45 times my original y2, so that's just u x to the fifth. And all of that should be equal to 0 once we find the correct u to plug in. A lot of the time you get to this step and then you're kind of confused what to do next. It's a mess of a lot of terms and it's unclear how we're going to simplify it. What can be helpful is to remember that this method is called reduction of order, and we always eventually get to that w equal u prime somehow simplifies it. And the way that works is because we always get rid of the lowest order term so that we can kind of only have to replace that u prime and u double prime. So from this step, you always want to group your u double prime, u prime, and u, and see that your u drops out so that you can do the reduction of order. So looking at my u double prime terms, I've got u double prime times x to the seventh, right there. And then there's no more u double primes. Then I've got u prime times 10x to the sixth right there. And to the 6th right there. And then no more u prime terms. And then I've got u times 20x to the 5th plus 25x to the 5th minus 45x to the 5th. And then 20 plus 25 is positive 45. So this positive 45 minus 45x to the 5th is all going to cancel out. And so this u term, just like we expected, is going to go away. And what we're left with is x to the 7th u double prime plus 15x to the 6th u prime equals 0 when all this goes to 0. And then since I see an x to the 6th and an x to the 7th, I can go ahead and cancel out that common x to the 6th, like divide everything through by x to the 6th. And so I've actually got x u double prime plus 15u prime equals 0. And then I'm going to go ahead and do my reduction of order step. Can you see if I write here? Yeah, you can. So I'm going to say w is equal to u prime. So I've got x w prime, because if w is equal to u prime, then w prime is u double prime, plus 15w equal to 0. And then I have to solve this for w, and then I'll be able to kind of go backwards, find my u, and then find my y2 in the very end. So when we see it written this way, hopefully it looks familiar, like a separable equation. Yeah, let's go up here. So I'm trying to isolate my w and x on opposite sides. So I've got dw over w is equal to minus 15 over x dx. And then I integrate both sides. So I get natural log w is equal to minus 15 natural log x plus some unknown constant. Natural log w is equal to natural log x to the minus 15 plus some unknown constant. We got to remember that power rule for natural logs. And so when I solve for w, I take it to e to the power, whatever's on the right side. And when we use our exponential rules, we find out that w is equal to some unknown constant times x to the minus 15th power. And so, since I know that w is equal to u prime, then u should be equal to the integral of w. So the integral of x to the minus 15 times a constant is just some unknown constant times x to the minus 14. So I'm running out of space here. And that would actually be c over minus 14 if you want to be really careful with all your bookkeeping, but you don't have to be because it's just an unknown constant. There we go. That's my u. And so my y2 is going to be whatever I found for u, c over minus 14, x to the minus 14, times x to the 5th. That's what I said right at the start. And the only thing is I didn't know what u was, but now I do. And so I'm going to get that y2 is minus 14 plus 5 is minus 9. Again, you can leave that c over minus 14 there. It doesn't really hurt anything. when you go through and write your general solution and then solve for your unknown constants, it's just kind of an extra number to have to worry about. So you could also go ahead and ignore it, and you'll solve for the correct coefficient when you do your initial value problem. So that's how to do this. I know they're a bit long. I did this in about 10 minutes, and I was, going at a reasonable pace. But another thing to think about is that this is going to be one of your presentation problems for your final project. And a lot of you may not be used to presenting math problems for just in general. So I thought it would also be good to take this time to talk about how you can kind of simplify your work in order to present a problem of this type. So kind of on your own, you would go through with your participation, solve this whole process and know how to solve the problem. Be able to do it, in 15 minutes, kind of sitting down on a piece of paper. And then you think about actually showing the important things. So as you were listening through this, think about the things that were actually important and the things that weren't. So this part where I went through and talked in detail about how to do all your product rules, probably useful because we're all a little bit rusty on calculus sometimes, but when you're doing a presentation, I'm not rusty on the product rules, so you don't have to worry about explaining that. So you could think about cutting out that step right there. And then when you go ahead and plug it all in, this thing where I kind of underlined and showed how I simplified everything, good for helping you follow it, but not good for being time efficient. So you might want to, I won't even delete the whole line, I'll just write it out here. And I'll talk through it afterwards so you can see how I would present it in that shortened form. And then once you get down here and you start simplifying things, this extra step where I went ahead and canceled out the x's, maybe I could have just explained that's what I'm doing, and then if I wasn't worried about losing you all, I could have just jumped right here. And then here I did my reduction of order. That's important for the method. Very important step. But all this stuff where I was kind of carefully reorganizing and going slow through that, less important. Because once you get right here, this is an exam 1 problem. I could have come here, said separable equation, do it, and then jumped basically to here. So that's what I'll do. And then showing you the integration, less important. That's something that you all learned how to do a long time ago. So maybe I just say I'm going to integrate it and that's what I get. And then coming back to the step and saying y2 was x to the 5th, that is important. It anchors us back to our solution. But showing you plugging it in and talking through that coefficient thing, not the most important part of understanding this problem. Instead, I could go right here and just say that's my solution. So now, we're sitting here at about 14 minutes into the video. I know it's quite a long one, but I'm going to kind of talk through this as if I was presenting it to you so you can see how it could be shorter. I'll be quite quick because I don't have to write as I go, but you can imagine if you were writing these steps, only the ones I say, it would go a little bit more slowly, but still faster than the original problem, which took 10 minutes. So I would come in and I would say, I was given this differential equation to solve along with this solution. When we do reduction of order, we always assume y2 is u times x to the 5th, but we don't know what u is. So we plug into the differential equation to kind of see if we can learn what u needs to be. To do that, I need my derivatives. So my first derivative is going to be this thing obtained by the product rule. And my second derivative is going to be this thing obtained by the product rule. I don't even have to explain how I got between the two. I can just say that that's what I did. Because that's not important to understanding how to actually solve this problem. then I plug everything in, and I can painstakingly write out plugging everything in. But when I simplify and group the like terms, I get this equation, and my u drops out. And so I'm left with this equation that only has u double prime and u prime in it. If you didn't want to write these steps out, you could also just explain in words what you're doing between these steps and then go to here. Once I don't have u in my equation anymore, I can go ahead and do the reduction of order step where I say w is equal to u prime, w prime is equal to u double prime, and that gives me this equation. I know from earlier in class this is a separable equation, so I group everything to opposite sides and integrate both sides. If you also wanted to skip writing that down, you could. And I can eventually solve this as w equal to some constant times x to the minus 15th power, following through some calculus and algebra. Then, because w is equal to u prime, I know that u is equal to the integral of w, and so when I integrate x to the minus 15, I get x to the minus 14. To finish out the problem, what I really wanted to know was y2, and I was missing u, but now I found it. So I can go ahead and plug in that y2 is u times x to the 5th, using u equal to x to the minus 14, and I find that y2 is equal to x to the minus 9. So a lot of these steps in the middle you actually don't need to include when you're thinking about presenting this. Just really think about what somebody needs to know about differential equations and say in words when you do the algebra steps. Don't actually sit there and show me that you know the product rule, because you'll run out of time if you do that, and you're more prone to like making errors and then kind of getting stuck and having to like think through how to do algebra. If you have a limited amount of time to show me that you know differential equations, it's better to just skip those steps.